And Mishra works at HashiCorp, as you may have seen in the slide. He's going to talk us about any infrastructure, any application, anywhere. So it's going to be an interesting one. So
thank you.
Thank you, Mishra.
Thank you, Ricard. Thanks, everyone. As you know, this conference is a bit special. Before I start, I want to say a few things. It's a bit special occasion for me because, of course, it's my birthday. Thanks for singing that. That's really appreciated. Also, this is my first time in Barcelona, and it's been so amazing. I would like to thank the sponsors and the organizers this conference. For the first conference, like, it's amazing. Like, even the video people and the AV people, this has been just an amazing experience for someone like me who travels so frequently and goes to conference. And yeah, this is pretty awesome. Third thing I want to say is, like, this is a special conference because the first time my whole team is in the audience. So when I say my whole team it's Nick and I, and Chris is here too from events at HashiCorp. So it's special for us. Nick is speaking tomorrow on Vault, so please come and watch his talk. It should be good. And yeah, that's all I have. So this talk is about bridging past, present, and future infrastructure with Consul. The idea is to kind of showcase the things that have changed in the past, like 17, 18 years, and what kind of, like, diverse set of applications that exist in production today in real life that people don't really see, and how to kind of connect them in a standard way. And then we'll talk about Consul, and I have some great live demos for you guys. Hopefully, since it's my birthday, these live demos will go smoothly. Hopefully, the demo gods and goddesses are with me. So a bit of a background on me. My name is Mishra. I work as a developer advocate at HashiCorp. Prior to this, I was a software engineer. I studied computer engineering. Then I graduated to be an operations engineer, which is where I think I learned the most. So the last 4 years have been working on infrastructure problems, building microservice platforms, and yeah, it's been great. So that's my past. And then currently I work as a developer advocate. So the role involves, managing the communities for all 6 of our open source projects, and work with different companies and things like that. So it's been really exciting. Also, one of the most, I think the most intriguing part of the role is me. I have the stickers, so I carry stickers everywhere. So that's like part of the job as well. That's in the job description, that you have to take these stickers from conference to conference. And also we do this, like, really fun thing. Nick and I, whenever we speak at a conference, we try to share something fun about us. So since we're in Barcelona, I want to talk about football. I'm a big football fan. I know, before anyone says anything, I know this is a very sensitive topic, so I'm going to be really careful the way I put it. Growing up, I've played football, like, religiously. I watch football. I wake up in the weekends. Even if it's 2 a.m., I wake up. I watch all the games. I watch La Liga. I watch EPL. I am a Man U fan. But growing up, one of the most interesting things, or one of the most interesting players that I've actually seen is Andres Iniesta. Like, he's, like, I think in my opinion, still, like, the best. I know there's, like, maybe some Madrid fans here. Like, I don't want to say anything. I don't want to start anything. Everyone's happy. OK, let's move on. Okay, let's talk about HashiCorp. We're less known for our name, HashiCorp. We're more known for our products. This is our regular marketing campaign about, like, educating people that there is a company behind these tools, and it's called HashiCorp. The idea is to kind of provision, secure, and infrastructure, like, anywhere. That's the idea. We look at the application delivery pipeline in 3 layers. One's provision, the other one's secure, and then the third one is the run layer. So the provision, this involves, like, provisioning, your developer environments using Vagrant, provisioning server-side images or machine images using Packer, and even building Docker images. And then Terraform lets you might have heard, like, during the course of these 1.5 days, there's a few talks that mention Terraform. So yeah, we're the company behind Terraform, and the idea with Terraform is to define infrastructure as code, and then let that be, and you can go and apply it, and then Terraform provisions these resources for you. So anything that has an API can actually make use of Terraform. Then the security layer is, like, Vault's responsibility. It's meant to do secret management and kind of control the secret sprawl that we have in our companies, which is quite crazy. And then the runtime layer, this is Nomad's responsibility. Nomad is our application scheduler. This is akin to Kubernetes and Mesos. And the idea with Nomad is, like, it can run containerized apps, so like Docker and Rocket containers. It can also do non-containerized apps, so you can schedule Java applications, standalone binaries. You don't need to containerize your application to make use of the cluster scheduler like Nomad. And then Consul, if you see, there's, like, it's a bit weird because it's like a distinct line across all the 3 products, so it connects all the 3 things together. It's a lot of different things, but in this talk, we'll only explore a few things. We also make enterprise products. This is how I make money. This is how Nick gets paid as well. So marketing, where's the camera? It's right there. Marketing, I did my job. OK, let's go. So in terms of like the open source projects, these are the projects. And we'll only focus on Consul for this talk. So before I start like this talk, I was asking myself, like, why do you want to write this talk? And what is so special about like connecting things from the past and present and future, which we'll eventually get to. And the premise is that like there's been a lot of change in the past like 17, 18 years, and that's the reason why we often find ourselves in like this really interesting, kind of hybrid or like diverse set of environment. So if you look at the history, right, if you take like 18 years, travel back in time, we started off with like these static instances, like these static servers that you bought and racked them up, and you would like connect them, you would network them, you would figure out cooling, you would figure out power and everything else. And this is how we delivered software, right, for like the longest time. These would be running in someone's basement, or if you're like if your company can do well, like Facebook, you have a proper data center, which is great. Right, that's how we kind of deliver software. And these things were pretty static, so if you would need like, more resources, or like, let's say you were doing a big launch and you had to do capacity planning, you had to buy all the extra hardware, you had to hook it up again and make sure that capacity is ready for you when you scale. You fast forward like, 17 years, and we're in 2017. We're in this cloud environment, or the cloud native era. Nick, this is for you. The cloud native era, in which like you have virtual machines, you have dynamic provisioning, and you have like this interesting environment when you're like using containers with VMs, you're using cluster schedulers. So things are pretty like dynamic. So you can ask for things. So you can say like, hey, I need 10 instances, and it's almost like an API call away. You can choose the cloud provider of your choice. You can choose Amazon, Google, Azure. They're all great platforms. All these other cloud providers. I don't want to say all of them, but there are many cloud providers. So you can choose any one, and then you can get whatever you want based on CPU, memory. You can scale anything, right? And this is great. So I feel like this change has actually changed the way we design software applications today, because now you're designing for the cloud, you're designing for the applications to be resilient to change, because these VMs can fall over all the time. Like Amazon sends you an email saying, hey, these VMs are going to get turned down like the next week or something, and then you have to figure out how to like move them. So your applications should be able to adapt to that change. So let's take a more like realistic look at this and kind of figure out like, how does this journey actually begin, right? So you start off with like just a monolithic application like everyone else. So in this example, let's just use like let's just build an e-commerce platform or something. So you first start with choosing a language. You either choose Ruby or PHP, because pretty much the whole world runs on PHP. So you end up choosing, let's say, PHP, right? That's your monolithic application. You put it on a server, then maybe you have a database. You connect it to the database, right? And then you realize, oh, like the performance isn't that great. So if you're lucky, you put a cache in there. It gives you some performance. And this is great. This works really well. And when things have to discover each other, it's pretty static, right? Like the servers are named something, right? The servers are specific to your name, or in this case, Star Wars seems to be the theme. The database is like you were testing in dev, but now this became the production database because you're a startup. You can do that, right? And then the way things discover each other is you basically hard code like everything. So like the application will have a config file, and you'll hard code like the address of the database. You'll hard code the address of the cache, and that's how discovery happens, right? It's pretty static. So now it's time to, let's say, scale. And let's say your business plan was really awesome, and your startup got funding, and you have all these users, and it's time to scale, right? You immediately start seeing like performance issues on the application. It's like, OK, well, we expected this. Like, how are we going to scale this? But you're very focused on features. So what ends up happening is like, OK, let's just throw money at this problem. Let's add more servers, right? This is the solution. And then once you do that, like, the problem is gone, and you're like, OK, this is great. This is fine. Then you realize your database is taking a hit because there's all these applications, trying to talk to the same database. Then you're like, OK, throw money at the problem. You get more caches. You're like, OK, this is great. You keep moving on. Then this is how we kind of statically scale this kind of, not statically scale, but this is how we scale this kind of monolithic architecture to an extent in which it's like an elastic band. Eventually, it snaps, right? And then you get outages week after week. And that's the time when you kind of invest in microservices. You look into service-oriented architecture. You figure out like, OK, what can we take out of the monolith so it can have its own lifecycle, or smaller failure domain. At that point, let's say in this e-commerce platform, let's just take out let's say the payment service or something, right? So you create its own microservice, and you see the monolith shrink from like that big monolith. Now it's a little bit less fat. Now you have like the payment service, which is separate in its own microservice. This microservice could be written in any other language. All it needs is API. It could be running in a VM or a container, right? It's up to you. Then you start like exploring this microservice-oriented architecture, and then as we all know, we really love it, and immediately you're like, okay, well, suddenly we got like tens and hundreds or thousands of microservices. It doesn't happen suddenly, but it does happen pretty rapidly in a software lifecycle. At that point, you realize each of these services has their own database, has their own lifecycle. You have to figure out how they network. You have to figure out how you want to connect these services to each other, to the monolith. That's when you bring in a cluster scheduler. So you bring in like something like Nomad, Kubernetes, Mesos, or whatever else. You're like, OK, we need a cluster scheduler so we can manage the lifecycle. So immediately you saw like the things became pretty like, it went 0 to 100 like really quick, right? Like, and then if you look at like the discovery problem, the upper half is still kind of static because you have still the same entry point. But the below, like if you see like these containerized applications, they are dynamic in nature. So you can't rely on DNS anymore because they'll have a unique name pretty much all the time when they come up. The databases might have their own unique names and stuff like that. Right? Discovery really becomes a problem at this point, right? You need a consistent or standard way to do discovery. So what we've seen in terms of like this transition, like the fundamental abstractions that we build software on are completely changed in the last, 15, 18 years or whatever. So we thought things as like data centers, physical machines, servers, IPs, and that's what we cared about. And now we've graduated to like this, like, in like platform, like containers, you're thinking about like, how do I build my Kubernetes cluster? How do I connect my Kubernetes clusters to Jenkins? You're thinking about containers, whether I should use Docker or Rocket. You're thinking about things as services, not as servers anymore. So a bunch of servers can make up a service, and then you just look at the service health and service discovery, right? And then in terms of the biggest change is just this transition from a monolithic application to a full microservice deployment. Exactly what has changed in an overview is this like idea of like having multiple cloud providers. So what this has done is like you choose a cloud provider. Let's say you choose Amazon or Google. Then you like, OK, I'm running VMs. I can spin them up whenever I want. Let's use containers. Let's use some serverless functions for something because it's a use case. You use some, let's say you use some like RDS databases or Spanner or Cosmos DB in Microsoft Azure. You can use anything you want. So you clearly see there's like a very like diverse variety of workloads running at any given time in your infrastructure. In terms of like how do these things actually talk to each other, the network protocols, you might graduate from using HTTP, like throwing JSON over the wire, to actually using protobufs and using gRPC, right? And you're like, OK, now we are like at the 1,000 microservice level, and we are seeing some performance issues. OK, let's move the protocol one to a more efficient one. And then also with like moving from TCP to 0MQ. This is one of the nice examples. Then there's all this other stuff that you need, right? You need like the config management. You need to choose a cluster scheduler. You need to choose the CI/CD pipeline. You need to choose, whether to run Jenkins or just use Circle CI or Travis or something. So there's all this stuff that you need to make software work. And at this point, the one organization that struggles the most is the operations people or the infrastructure people that, I don't want to say DevOps people, but like infrastructure people are the people that are close to the infrastructure. They're the ones that basically take the biggest hit. So developers might come up and say, hey, we need like Hadoop to do large-scale data processing, and then give us a Hadoop cluster. And the infrastructure people are always taking a step back and be like, holistic view, like, OK, we bring in Hadoop, like how do we provision it? Where should it run in terms of security? We think about network. Then you think about how the applications are going to consume this data. So they're the ones always thinking holistically rather than being like, oh, I'll give you this keys. Don't worry, like I can just spin it up for you. I'll give you the SSH. I'll give you the credentials. I'll give you the host name. They're always like reserved, right? And there's a reason for that. That's because like they're worried about like how do I make a consistent way to actually do things, right? And that's where like you see that they're the ones they're always like in trouble, right? This is not a take on Windows. Like I love Windows. I want to be clear. I just love this GIF. I'll stop it. But like the thing is that they're the only like people that struggle the most when it comes to creating a holistic view, looking at things holistically, versus like people that are very focused on features. They want to get their code out. Okay. So in terms of challenges, as you saw through this journey, there's a few pretty obvious challenges. The first one is just networking, right? Like, how do things communicate with each other? How do we connect different applications of different, something running in container with something running in a VM, something running in a bare metal? How do you connect those? And then, actually, in terms of networking, network actually becomes the common denominator when things are changing around it. It's always your saving grace that, OK, hopefully the network will save us, because that'll be consistent. We'll do things using APIs, so that'll save us. In terms of discovery, this problem is always going to be a problem. Like, you still need to discover these dynamic applications, dynamic workloads. And then configuring, you also need like some kind of way to like dynamically configure your applications or like inject that runtime thing. So let's say you have an artifact, let's say a Docker image. You promote it from dev to staging to production. Each environment has its own databases, so you need to inject that last minute, like, this is my database in staging, these are my keys for like contacting this other API. Also, you need to do things like feature flags and things like that. Or even like take things down, do maintenance on a server and things like that. So you need like some way to dynamically configure these applications. So in terms of challenges, these are the big challenges: service discovery, runtime configuration. And the most important one in my case is this common interface. And this is the premise of the doc, which is like, how do you provide a standard way to do all this, right? And it's been a problem for like the longest time. And we have different solutions to it, and we've been doing that. But this talk is just to highlight like some of the practices that you can do. So this is where Consul comes in. And Consul kind of provides, it's an open source tool by us. It provides a lot of these things right out of the box. Some things you need to configure it to actually get the most out of it. Consul is a lot of things, but I'm only going to focus on a few. Consul is a service discovery tool built in Golang. It's just a single binary. You can get the service discovery data using DNS or HTTP. I'll talk about this in the next few slides, how that works. Then you can use this for health checking even. So you can tell consoles like, hey, services can just expose a TCP port, or they can expose like an HTTP path or something, like a health check. And then console will just health check based on whatever you configure it. And then it also provides you with a consistent key value store. So you can use that to dynamically configure your apps. And I'll explain how that works too. So in this talk, I'll only be focusing on these few bolded points or whatever. So the first thing, how do things find each other? That's like the first problem. In order to understand this, we want to kind of explore how Consul works, and that'll give you a good basis of like understanding how Consul solves this problem. So Consul's architecture is pretty straightforward. It's a very traditional server-client model. As I said, with most of the HashiCorp tools, it ships as a single binary. It has two modes. One's the server mode, one's the client mode. And in this case, like, there's 3 servers, and there's a few clients. So all these things are communicating with each other using this gossip protocol, and which is basically like random communication to your neighbors and like making sure they're up and things like that. And then the servers, if you see that this one, like the middle one, has a star on it, it's the leader. So the servers actually do leader election using Raft. And then once the leader is elected, it's responsible for keeping state in the cluster. So it's responsible for replication. It's responsible for a few other things. But what's interesting is that any one of these clients can actually do an RPC call to any one of these servers. So it can be a follower or a leader. And let's say if it does to a follower, the follower will just like transparently forward the request to the leader, and leader will respond only for certain requests. And this allows like the clients to be like, I don't care. I'll just fire off this request, and then hopefully get a response based on whenever the leader responds to it, basically. Consul, right out the box, also supports multi-DC strategies. So let's say in this case, the upper diagram is for US, and the lower diagram is for Europe. You can connect these 2 data centers pretty easily using a very lightweight WAN gossip. And this is basically clients in, let's say in Europe, a service in Europe can ask Consul, it's local servers, it can ask like, give me the database that's running Redis in US, right? And this request will go to the servers. These servers will just transparently forward using the WAN gossip. This is over the public internet. And then it'll go to the other servers in East, in US, and those servers will respond, and it'll reply back to the EU servers, and EU servers will forward it back to the client. But the client, and in terms of a client or the application, they don't know this is happening in the background. They just fire out a request saying, I need the healthy instance of a Redis server running in US. And that's all they need to do, and then they'll get the answer back. So in terms of how this thing actually works, so you run these Consul agents on everything. You run it on all their nodes. In this case, the top ones are just servers. This is just a simple server that's running a front-end application and maybe a proxy for connecting to Memcached or something. And then each of these things can register with their local agent, and they register themselves as a service. They can use config files, or they can use the HTTP interface. Once you do that, this agent, local agent, is responsible for propagating this information across the cluster. And then let's say you have another service called the backend service. It can do the same, right? It'll do the registration, and the local agent there will broadcast that information. And then let's say if the front end had to talk to the back end, there's few strategies for it. So we'll explore the first one. So let's say if the front end makes a request, give me the back end service or something. So the way that works is pretty straightforward. So you can use the DNS interface. DNS is pretty much like used by it can be used by any application, older or new application. So you can just do a dig here, and let me break down the actual service call here. So the first one is the console TLD, basically tells the server, it's configurable, you can change it to anything you want, your company name or whatever. But by default, you get console. And then that basically tells the DNS servers, hey, delegate this to the console's agent's DNS server. So every agent exposes a DNS interface. And then the service in the middle is the type of the thing that you're looking for. In this case, we're just querying a service. And then backend is the logical name of the service you want to access. So in this case, backend is the service's name which it registered with on the previous slide, if you remember. And you get a DNS response, which is a pretty straightforward dig response with a bunch of A record entries. And these are the healthy instances of the backend service. What's interesting is you can effectively, and a lot of people don't use this, but you can effectively use this to do load balancing. So if you query the same DNS query again, console will actually shuffle the records. Now watch, it shuffles it. It just, it makes just like a round robin shuffling. And this effectively is just like a round robin load balancer without running a load balancer. And then this information is also accessible on HTTP. So if your applications want to do something advanced, they can use the HTTP interface. And that's just on localhost. The default port is 8500, but you can change it based on whatever you want to set it to because of security reasons or whatever. And then, the path is v1, health, service, all the APIs exposed under v1. And then the backend is the name of the service. In this slide, all the results don't fit, so that's why there's ... but that's how the result is. And then I talked about the key value store. You can access the key value store locally from any agent based on, console also has an ACL system, which I'm not going to talk about. But based on, if you have privilege to write to that key, you should be able to. So you can just do console kv put. In this case, I'm storing the world value into hello. And console will say, I've written it, right? And then you can get it out as well. So you can say console kv get, and you get the value back. You can do this with using HTTP as well. So here you just do a get for that kv value, hello. But what's interesting here is the value comes back as base64 encoded. So here I'm just doing some bash to actually show you that this is not a joke. It's actually word. So that's pretty much what I have for the slides. I know it's pretty small, and now I'm going to actually do a series of live demos. We all pray to the demo gods and goddesses at this point. Hopefully this works out. This is probably the most complicated demo I've done, so 100% it's going to fail. So it's great. You'll watch it fail, drastically as I go through this. OK, so let's do this. So here we're going to actually do, we're going to actually use this this one application called Giphy Link. I hope everyone can see it. I haven't can everyone see it? Should be good? OK. So yeah, that's the application we are working with today. This is my own. I made this startup 2 hours ago. It's called Giphy Link. And I think it's going to get funding. I know it's going to be successful for sure. There's a 100% guarantee. So the way it works is you just ask this, well, how do I get to this? OK, there we go. You ask this app anything. So let's say you ask hello, you say hello. And then it gives you a gift back saying hello, whatever from the Giphy link is. And by the way, if any demo works, you should clap while you can interrupt me. It's fine. I'll accept the claps anytime. So in this, you also get a shortened link at the bottom there, right? And that shortened link basically redirects you to the actual GIF ID. And that's my startup. So if you go here, so yeah, that just gives you back the actual GIF, right? So that's the startup that we're working with today. It's pretty small scale, but I know it's going to be successful, of course. So let's actually look at the code here. So 1 second, let me put my notes on so I don't miss anything. OK, so let's actually look at the app here. So hopefully we can see this. OK, this is it too small? It's Ruby, by the way, so you're gonna love it. Can everyone see that? App. OK, so we'll open this app. I hope everyone can read that. I'm just assuming that that's the case if no one said anything. Otherwise, yell at me. So the way this works is it's a pretty straightforward app. It uses a Redis backend to store like all these shortened links and stuff, and it just does a Giphy call. So if you go to the main main function here, you see this is the post main function. All we're doing is like taking a keyword, which is this keyword, right? We're taking that keyword in, and then we are just like making a call to this get image function. And this get image function is, okay, here we go. This get image function is here, which is this one. Here, I'm just like reading the API keys. I'm not giving out the API key, security. And then, this is not the best practice or whatever. And then this is the API URL, and then I'm just creating a link and just querying like with the keyword, passing the API key, and limiting the results to 5. I'm just going to pick the first result, because that's the most optimized algorithm I could come up with in 2 hours. And then return back like the embed URL and like return back like the GIF URL and stuff. And then after that's returned, this handler also does shortening. So it takes in the link, it creates a random shortcode, and then it stores it in Redis with like just a set 9x, right? So it's pretty straightforward, nothing fancy. There's also this shortcode. There's also this shortcode like endpoint, which is used to redirect things. So it takes in the shortcode, it takes in and does a query to Redis, and does the 302 redirect to get to that app. It's pretty straightforward. So now, since we were like a startup, we started off with a pretty straightforward thing. There's nothing complicated going on here. The Redis server is actually running on the web server itself, of course, because that's how you start. So let's actually validate that I'm not faking this. So do this. Of course, authentication. No one saw that. OK, I clear my screen. Do info. OK, so if you do info, like you'll see, like this is actual running Redis instance, just running on the web server, which is what we want. So now let's see, like let's say we got like 100 users, and like 100 users using this. You're like, oh shit, we're going to move this. Like this thing, Redis like thread is like taking too much CPU. Let's move it outside the server, and let's actually create its own database, which is like the basic thing that everyone ends up doing. So let's exit here. I already have the server up and running. Yeah. So yeah, we are here in the DB. Yeah. So let me increase this. Yeah. So this is the Redis server. If I do Redis CLI, just making sure that's up. Info. Oh, please don't have password on it, please. Oh, let's do a ping. Oh, OK. Info. OK. Here we go again. OK, no one saw that. OK, everyone saw that. God damn it. OK, so this is another Redis instance that's running in a separate server. Now we'll try to discover this using console, right? That's the whole point. So we want to discover this server, not like hardcode the IP and like do like classic like, oh, let's do ifconfig, let's find this IP and like just copy paste this in the config file. No, we'll actually try to discover it dynamically and use that DNS interface that I was talking about. So to do that, we want to bootstrap the console cluster. I've already done that. I'm already running. If I go back here, I'm already running a 3-node console cluster in GCP. It's running in Europe, of course, because we are in Europe, less latency. And then that's it, right? So we go to the console server now. Where is this? Sorry, there are too many screens for this demo. As I said, it's the most complicated demo. So here, that's one of the console servers in Europe. We'll just do console members, which basically gives you all the console servers. So in this case, OK, right. We'll ignore the last two servers there. Just ignore that for now. This is my bad. The first three ones are the 3 servers that we see. They're the ones running. Actually, I can just refine this to Europe. Yeah. So the first 3 ones are the ones that we want to focus on. These are the 3 console servers. They are the ones that keep the state and things like that. Now the next thing we want to do is actually start running the agent on the database server that we just had, which is this one. So here, all we'll do is sudo service console start. OK, we have the thing up and running. Let's do console info. That'll give us whether, OK, there we go. It's alive. Next thing we want to do is actually register this Redis server as a service in console. So let's go to console. You can do this using the file, the static file, or use the HTTP API. It's up to you. In this case, I'm just using a file. So we'll call this service GiffyLink DB, and it'll run on 6379, which is the default port for Redis. And then in terms of health check, I'm just like running a random script that just does a ping and gives a Pong response back from Redis. And it's a very basic test, so not production grade. This is one instance, so you can have Redis and clustering and things like that in production. We're not going to try doing that. This is already too complicated. So yeah, this is the service, and I think this is already, since I already started, oh my God. Okay, here we go. Since I already started the console service, so it's already picked up this check. So let's go to the UI and see whether this is up and running. So here you see, hopefully, yeah, Giphy link is up. It's passing its health checks. It's giving you the Pong response back. Hopefully everyone can see that, right? So that's good, right? So we have it in the service catalog for console. Now we can actually start using the DNS interface. So now if you go back to, where is this? The web server, which is here, right? I can just do a dig for Giphy link. Oh my God, yeah, like Giphy link -db.service.console. And we'll get a response back with like only one instance of the server that's running. You'll notice there the TTL is set to 0, which means the local console agent isn't caching any results. This is coming all the way from the server back to you. So if you want something like that has a really like high read intake, like really high read rate, then you can actually set some TTL, and if you're okay with the entries being stale, that works as well. So that'll basically increase your performance in terms of reads. But yeah, the TTL is 0, so immediately if the Redis server goes down, this record will disappear. That's the idea. Okay, so we have that up and running, so let's hook it up to the Ruby app. So I'll open this. Here, I was just setting this, which was set to localhost, right? I'll move this out. I'll just comment this in. By the way, I learned Ruby like 2 days before, so it's great. And here, in the DNS, you see I'm using like the console qualified DNS name. That's it. Save this, and then all I have to do is Ruby. This is not how you run a production-grade Ruby class, by the way. Do not like code me like, I saw Mishra do this demo, and this is how it should be done. No. Even if you add like a and in the end, at the back, like just to background the process, it's not the production way of running it. People think that that's the way to do it. No, that's not how it works. Where is this? There we go. Okay, let's refresh. Okay, so this is still working. Let's try to like actually query. Let's do Barcelona. Oh, Messi, of course. Okay, so the first part worked of the demo. I'm glad that worked. So fairly complicated. So what we've done is we've moved the database out. We've discovered it dynamically using console. We've bootstrapped console, which was interesting too. I'll actually talk, if I have time, I'll show like how the bootstrapping process works. And then hopefully there's an image somewhere. Oh, the URL there too. Let's actually try the redirect. Hopefully that works. Yeah, there we go. So everything is working, right? So at this point, you realize like, well, this is the time to go to microservices, right? This is the time when things have to be written in Golang and Rust and everything else that you want to write your services in. And then we'll pick a part of this whole monolith and take that out in a microservice. So let's open up the terminal again. Where is this? OK, here we go. OK, come on. Bash history is your friend. You open this up. Yeah, so here, what we'll do is, like, if you look at the actual main handler, we're doing only 2 things, right? We're like doing that API call to Giphy in a function, and we're also like doing the Redis stuff, so we can make either one of it as like a microservice. So let's actually just take the first function, which is the get image function, and convert that into a microservice. Now, this has already been done for the demo purposes. I'll show you the code, but the idea here is to understand, like, at this point in an organization, in reality, you bring in a cluster scheduler, so your operators are like spinning up these cluster schedulers for you. So it could be Nomad. In this demo, we'll use Nomad, but like, it could be Nomad, Kubernetes, or Mesos, or whatever else. And that takes a lot of work. Like, but we'll see if we can, make this Nomad boot up process easy. Let's see how easy it is, right? So in Nomad, let's go to Nomad. Yeah, there we go. So here I have 3 Nomad servers that are running. Also in Europe, I hope everyone can see them. These are just running the Nomad binary, as most of our products. Nomad also ships with a single binary with 2 modes, server and client. It follows the same principles as console. A lot of things that we learned running console at scale in production, we used it in Nomad as well. This talk is not about Nomad, so I'm not going to explore much about Nomad. But all you have to do is actually start the Nomad servers. But what's interesting is, first, I want to show you the config file for Nomad. So if you open this, I think it's Nomad, yeah, server.htl. So if you notice, hopefully everyone see this. There's only like few things that are defined. The addresses are just like the address of the actual instance. So that's just the address of the server itself. And then there's a Nomad uses Surf, which is the gossip protocol, and then RPC, which is a remote procedure call, and then the HTTP exposes 3 different services. It advertises them. And then in this data center is like Europe West 1. The region is US for some reason. I don't know. Let's leave it there to that. It'll break the demo. And then the data there and stuff. And we're also saying expect 3 servers to consider yourself as bootstrapped. And then that's when the leader election will happen. But what's interesting is I'm not providing anything in terms of like what are the other servers that you need to communicate with, right? That's not actually specified here. And most of the cluster schedulers, if you have experience with bootstrapping etcd or Zookeeper, you need to provide like a connection string to other things. And then they discover, or you can provide that like dynamically using console or something, but it's not built into the thing. Since this scheduler is built by us, we have a native integration. When I say native integration, it's just an HTTP call to console asking for things that are running other Nomad services. That's all. So we'll start Nomad. So we'll do sudo, actually I'll just do it on all. Sudo service nomad start. And then do nomad server members to make sure if you're able to. So here we bootstrap the Nomad cluster. That was it. The way this works is it queries the console catalog. It says, hey, what are the other servers that are running the Nomad process in this data center? Then it tries to do a join with them. And if it doesn't work out, it doesn't work out. If it works out, then you see something like this. We also, in that time, also did leader election, if you realize. We have a leader right here, which is Nomad Europe West 3 or whatever. So that is a leader. So now our cluster is bootstrapped. Now we need to actually bootstrap the client nodes that actually run the workloads. These servers deal with like all the scheduling and coordination and stuff, but the Nomad clients are the ones that actually run the workload. So let's bootstrap those as well. These ones require a lot of work. When I say that, it's basically the same thing. There's nothing special to this. You just start the Nomad process here too. Sudo service, if I can type, nomad start. And then we just do, if we go back to this, go back to the servers, we just do nomad node status. And we see the 2 clients are up. They are almost, they're ready. They're eligible. They're using the new Nomad 0.8 version that's coming out tomorrow, but this is the dev RC release. This is fresh off the press. So if the demo fails, it's the Nomad team, it's not me, so it's great. So I put the blame on them. This is on video. Oh, shit. Okay. Well, whatever. Like I already said that now. Okay. So that's the idea here. So we have 2 nodes. Let's actually run some workload on it. So we go back to our terminal. Hopefully we have something that I can run with. Come on. Sorry, there's too many windows. Yeah, this should work. We have Nomad. Here we have the jobs. So, okay, so first, actually, let's talk about that microservice that we were talking about. Sorry, I dropped the ball there. So let's go back to the code here. So here I have a microservice that we're going to schedule. This is right here. So yeah, I hope everyone can see that. Yeah, so the microservice we're going to schedule is written in Golang. All it does is the exact same stuff that the function does in the Ruby service. It's the exact same stuff. So it takes in this case, don't worry about this April Fool's thing. I'm going to show you something cool later. But yeah, so it takes in the HTTP call. It goes to this Giphy handler. Hopefully we can zoom out of this. So this is the Giphy handler. And all this does is reads that keyword, the hello or Barcelona, whatever else, and just does that API call right here, does some JSON stuff, and in the end returns the response back. Again, we're returning, if you see, where is that return statement? Oh yeah, we're returning the embed URL and the image URL, which is the exact same, right? So it does the exact same stuff that function did in Ruby, right? Now let's actually deploy this. So we go here. We look at the Nomad deployment file. Let me just switch and give you a nice editor output rather than the cat. So yeah, that is the Nomad file, the file format. If some of you who've written Terraform, you might be familiar with the HCL language. It's our syntax. It's meant to be human readable. It's JSON compatible. And this is pretty straightforward. In this, I'm saying like run it in data center US West 1, which we just bootstrapped. We are saying we need one of these things. Don't worry about the other details. We'll skip those. We're saying this is a Docker image to use. We are using the driver Docker. As I said, Nomad supports other things as well. That's why you have to specify Docker. And then also, what's interesting, if we're registering this service called image search, and we're exposing the health check, This is a console integration. That's it. So in the background, Nomad deals with making sure it watches the console does all the watching, but Nomad listens to those events, and all that plumbing is done for you. So no more like writing that in like that JSON file that we did for that database and stuff. That's all gone. Here is the Giphy API key. OK, we'll skip that. And then I'm setting a set of resources like CPU and things like that. That's all. OK, so let's zoom out. Let's actually schedule this. So we are in jobs. I hope everyone can see this. Nomad also has a plan command, which is interesting. We can do Nomad plan. Oh, why is this? Image search .nomad. Oh no, what happened? This is where the demo got, hey, we will recover live. Watch this now. We will, otherwise this is not good. I want those claps. Where is this? OK, so connection refused. Why you gotta be like that? There we go. OK, that's working. Is it? Oh no. Oh no. Hold on. OK. It should be working though. What might have? Yeah. OK, that's working. Just taking a little longer. OK, that's fine. And then where were we? Sorry, there's so many windows. OK, there we go. So yeah, we are successfully running a plan which basically defines, which is very similar to what when we look at Terraform. Terraform has a plan command. So you actually predict what you're about to run, basically. And Nomad tells you this allocation is mostly safe to run. So let's run this. So you say Nomad run. I'm going to speed up here for time. Image search, and we run that. Hopefully it's scheduled. So Nomad schedules that pretty quick. We do status. Hopefully it's in the batch history. Nope. Nomad status, and we have that job, and it's running. We can actually just get more info. Search. Bless you. And you see, like, it's running, right? It's in running state, which is all good. OK, so now, logically, if everything just worked as we expected it to, this service is up and running in a Docker container somewhere in one of those 2 nodes that we have bootstrapped. But what's interesting, it should also show up in console. So if you refresh this, we see there's an image search, and there's the other 2, like Nomad broadcasts itself as a service, and the clients as well. So this health checks itself as well. So ignore those. But most interesting is like that image search service is now actually available to be consumed using DNS as well. So this microservice that's running in a complex cluster scheduler, which we bootstrap right now, and it's up and running. It's available. So let's actually try using it. So let's go back to this one. Yeah, there we go. OK. So let's first start with a dig. Let's start small, right? Like before the demo fails. Image search dot, what is it? No, service. Oh my God. Service dot nomad. Oh. Sorry. Yeah. So we get a response back, right? We say, like, we get one IP back. This is the IP that's running that instance. That's running that instance of Docker container. We're good to go. Next we just added this Ruby file. And let's start using this microservice. So to make things easier, I've already inserted the code. So I'll just comment this line out. I'll comment in. I wish microservices were this easy, right? It's just, there we go. It doesn't work like that, though, in real life. So here, I'm just calling this new function, the image search service function. And this, as you can see here, is just calling the image search API on the fully qualified console DNS, and then does the query to console and gets response back. Again, it's just returning the same things back. All right, this is the tricky part. If this doesn't work, then I'm going to leave the stage and say, this is game, it's game over, basically. So hopefully this works. So production-grade Ruby deployment. Here we go. Oh my God, who's this? Like someone's like DDoSing it? Great. We say hello, we get it back. OK, that's good. Oh my God. And then let's try the redirect. That works too. So now we have a monolith that's connected to a microservice that's running in some cluster scheduler and inside a Docker container running in front of you all, which is great. No claps. OK, pretty hard audience. Pretty hard audience. OK. I don't know how much time I have, but OK. So is it time up, actually? No, I have like few more things. I don't know why the lights came on. I have like last few more things. I know the questions, we won't have enough time for questions, but I'll take questions on Twitter or outside of the talk, so don't worry about that. I'm here for the whole conference. So I'll finish my talk. So in terms of like the next few things which I want to talk about is like, actually let's take this a step further and like connect Kubernetes. Of course, we have to use Kubernetes. Get Kubernetes in the game, and let's say like you're working in a larger organization, like something like Visa or like some big company, and they have different teams, and these teams are almost like their own companies. So some team wants to use Kubernetes, some teams want to use Meso, some other team wants to use Nomad or whatever. They have to actually make this work, right? How does that work in this scenario? So you can actually configure. I'll go pretty quick. You can actually configure console DNS interface using kubedns. So some of you that are familiar with Kubernetes, Kubernetes service discovery is DNS-based, and it uses kubedns as like the backbone. You can configure kubedns to actually watch the console's DNS interface, and all the queries that go under the console TLD can just be proxied and discovered. So actually, let's quickly do that before they throw me off the stage. I'm going to stop this. I know what you all are doing, this DDoSing going on here. OK, so this is the Kubernetes deployment. It's a 3-node deployment. As you can see, it's pretty straightforward. It's also on GKE. What we can do here is, first off, just do kubectl get pods. Oh, actually, no. Kubectl get nodes. Just make sure nodes are online. Okay, so we have 3 nodes, and it's like a pretty standard like GKE deployment. Like I'm not setting this up using Terraform or anything like that. It's pretty straightforward. All right, so next thing we do is just run our new microservice, and I've already written this microservice. All this microservice does is counts the number of links that are shortened in the Redis database, and then you all can actually use the service and show the number go up, which will be interesting. So let me just deploy it, right? So I'll just say kubectl apply deployments, and the microservice is called link count, I think. What is it? Key count? Sorry, yeah, there we go. And then we do get pods, and it's up and running, right? And then let's access it. We'll do port forward, and then we'll go here, and then I'm just going to port forward to my local host port, 8080, and let's count the links that were shortened. So it's 25. Let's actually bring up the, Let's actually bring up the app again so people can use it. OK, here we go. Someone's going at it. OK, and then let's go back to the window. Where is that? Oh, link count isn't going up. Why is that? Oh, maybe I should try this again, actually. 1 second. Let me shorten like something. Oh my God, what was that? I'm actually scared to go back to that screen again. Like, what happened? So yeah, that number went up, right? It's 27. If you all use it on your phones, you'll see this number go up. That was the whole idea. OK, so someone's using it, which is good. So yeah, that is the last part. So what's happening here? Like, I'll quick glance on what exactly happened is if you do kubectl get a config map. Oh, no, not this. Config map. Oh, no, not this. I have it somewhere in my notes. This is Kubernetes, so I'm not. Where is this thing? Nope. Provision. Sorry about this. I just want to show like what exactly does the this one right here. OK, so this is the actual. I can just do it here. So this is basically the DNS integration right here. So here what I'm doing is in the kubedns config map, I'm just injecting the console TLD and telling it to follow this IP. And this IP is for the service of the kubedns service. So if I do kubectl get svc, and I say, give me the console DNS service, this is the service IP for that service. And this service is housing like few console agents that you saw in the earlier output. So if I do kubectl get pods here, and then I just grep for console. These are the 2 console pods that are just running client agents, and these are the ones exposing the DNS interface. So the service points to the pods. The service is used by kubedns, so anything that comes under .console is used. And then in this microservice, if you look at the actual not this file, but key count file. This is the Kubernetes deployment file. I'm just saying the Redis address is now giphy.db.service a thing. So from Kubernetes, we are able to discover a database that's running in some VM using their Kubernetes native DNS service discovery. So like, in terms of Kubernetes, you aren't doing anything special except for that config file. So you aren't like snowflaking something in. So you can connect like legacy databases using Consul into Kubernetes, into Nomad, and you can use it this way. I think that's pretty much it. I think I have like one last slide. If I have yeah, there we go. Okay, so in terms of like conclusion, Consul is run at massive scale. It's run like in tens and thousands of nodes in different companies around the world. Few of the companies that I wanted to talk about is these companies. We don't really talk about like the companies that use Consul, but there's, you can see the names there. So Verizon is a big US provider, telecom provider in US. There's PayPal and Stripe that are big payment providers. Then there's Cisco, which is pretty much everything. Then GitHub, Twitch does video streaming. And then there's Visa and SAP and Comcast and Capital One, Target, Home Depot, all these trusts. So this is not a project that runs in my home at a Raspberry Pi cluster. This is actually serving all these people in a massive scale. So in conclusion, like I want to tell you all that keep things simple. Like if you can use DNS, do things simply, just use simple building blocks. It'll helps you move in a dynamic cloud environment. You don't have to do anything complicated to get and achieve the reliability that you want. You can do that by just like, you don't have to use Consul. You can use any other service discovery tool, but have a standard way of like exposing this information using protocols that are like understood by different applications. And that helps with like the journey of, through this cloud era. And then so in conclusion, Consul helps you discover and connect applications at scale. Thank you for having me, really appreciate it. I have stickers, you can ask me anything on that handle. I know I don't have time for questions, so I'll go off the stage, but you can meet me at the conference hall. Me and Nick, you can just talk to any one of us and we'll answer all your questions. Thank you, thanks for having me. I don't have time for questions.
Yeah, we maybe can take one or two quick ones while we are setting up the next speaker's laptop. Maybe.
If anyone has questions. I don't think there are no questions. Okay.
Yeah, Nick has one, okay.
It wasn't really a serious question, I apologize. Can I have some stickers, please?
We still have some stickers downstairs, like so if you want some.
Not for Nick, I'll give it to anyone else, but not for Nick.
Okay, thank you, Mishra.
Thank you.
Thank you.